I want to prep you a little bit for the board side of it. I'm not going to do the work for you here per se. You can ask about it. We can sit down and look through it, maybe even in class. But I want to at least give you some idea. Now, first of all, to have the board work, you probably need to get the piece working first. If you haven't done that, either go back and watch the video for the piece or build it. Get those tests passing. There's a separate set of tests for that. That I want you to be aware of and to go and look at. So the board class has a few diff things I've defined for you. So the first being is I'm trying to find the off-limit spaces. So if you think of a Stratego board, there's four spaces in the middle times two. There's two four-space squares in the middle where players can't move. It's kind of a way to funnel players into a specific battle zone and then give you a space where you can like stack up bombs or whatever you want to. And then also, I've defined where the red and the blue players get placed. So basically, what I'm saying is the red players are down at the bottom, the blue players are at the top of the board. And so I can place the blue players on 0, 1, 2, 3, and the red players on 6, 7, 8, 9. As far as the spacing goes. That's what these constants are up here. Now remember, these are not attributes. These are categories of the board class that's true for all boards, for all the games being played simultaneously. The information you want for the specific board is down at the bottom here with the init. So I'm defining a board as being a list, but you're going to do as a list of lists. You have a list, basically 10 lists of 10 items, so a 10 by 10 board. Um, and that's going to be one of the key things that you're going to be filling out for the exercise. And then you're going to have the current player is going to start off as red. And then I'm giving you a piece factory, which is a helper for you to be able to work with. But notice here, I'm actually setting up the board for you. So I start with a list, but I give you a list with 10 rows that each have 10 times none inside of it. There's no pieces on the board to start with. So the board is set up. And then there's a string method which will print out the whole board. Now, one thing to note here, I am using a extra helper which adds color to the board to print out, but only if you're working in idle. If for some reason you're using some other tool other than idle, this print C won't work. Your colors won't work. You can either tweak the helper here, and I can show you that. The helper here is the idle colors class right here. You can tweak this and change the definition of print C to kind of not do the color map stuff and not put the colors around them. And you can play with that if you want to, or you can just take this out and kind of print it on your own or redo it on your own. But again, this is one that's built for idle specifically. The other thing I will note here is the piece factory. The piece factory has all the rules for getting the name of a piece based off its rank that help print it out. To get the symbol, this is for printing it out mostly, but then it also builds all the pieces or individual pieces for you. So if you need something from Piece Factory, it's there. I don't know that you necessarily do because my test cases should be handling that for you. So what are you doing? Well, the first couple is pretty straightforward. There's a getter and a setter. Who is the current player's turn, or change whose player's turn it is. And that's based off of just simply the current player. It's going to be red or blue, and you either return the value or you allow it to be set by the controller that's calling the board. Whoever's playing the game, saying my turn's done, it's now the other player's turn. That person's going to call this. I want to have this idea for you that you no longer have to control everything as you're building a class. You just define the bounds that which you control. And it's not your job as the board to decide whose player's turn it is. You get told who it is and you keep track of whose player it is so you can draw the board accordingly, but it's not your job to change whose turn it is. Again, this is important though because the way the board draws is if it's your turn, you get to see your pieces. You don't get to see other players' pieces, and vice versa. So it's kind of a cool feature as you get into it and start testing on how it's going to draw the board. So the functionality you're mostly concerned about, the tougher ones, is you're adding pieces to the board. So when you add to the piece of the board, well, based off of what color the piece is and where they want to put it, it may or may not be legal. It can't go in the off-limits space, and it can't go outside of the red or the blue starting space. So that's one of the bits of logic you have to do. The rules for moving a piece, well, a piece can move up, down, left, right, one position unless it's a scout. My suggestion, make it move for all the pieces and then worry about the scout. If a piece moves onto another piece that's already on the board, well, then an attack happens. And so you don't need to reconcile the attack in board. You've already coded that in piece. So you just say the two pieces, one attacks the other, and take off the players that are no longer active after the attack happens. Um, some helper methods that might help you do some of this work, or maybe somebody else do it. Well, get whatever piece is at some location. So you have a board with, again, 10 by 10 board. Somebody says this row and this column, return whichever piece is that location. Or the opposite of that is if I hand you a piece, then scan through your board and tell me what location that piece has. It's going to return it as a tuple where row and column come back as two numbers. Um, so these behaviors start to get you a feel for how to build a class from the inside. Working on a class from the inside is really nice because I can define very specifically the behaviors I want to implement and the bounds in which I want to implement them. And I can test those things independently, and it's up to somebody else to put the pieces together, in this case, the coding pieces, to create the larger application. All right, so there's a little bit of some guidance on how to get started with this. Again, this one has a test board. I still want you to play with this idea of calling a class from another entity. And so when you hit F5 on this, you can see I didn't return the expected piece. I returned none, but I expected the piece to be red. So there's some checks and balances here of inside of it based off of you setting up the board. And so the tests that are going to happen here at kind of a quick high level here, a lot of tests here. But I'm going to test the basics of the board, and I'm going to test move, and then I'm going to test the scout move, and then I'm going to test attacking as the last bit. And so you can build these in order. You can build these, one at a time and get each one to work in turn. And then there's a lot of code here to test if you want to check it out. There's a lot of points on this one, so earn the points that you can. Ask for help if you need it, but it's a nice challenge of working within classes that'll really stretch some of the knowledge you've worked with before. Now, in the idea of working within a class and using attributes and methods to solve problems.